Alright, now there are certain shortcuts that we can use once in a while if we're given the right circumstances. Now, one of those circumstances is going to let us do something that's called synthetic division. Now, synthetic division can only be used in a couple circumstances. And the main one is if we end up getting something that looks like this. X minus a is what we're dividing by. If we get x minus a for our division, in other words, x to the first power minus some number, or x to the first plus some number, we can use the synthetic division idea. So let's take a look and see what does this synthetic division look like. Well, here's what it is. Let's say we've got something generic like this. ax squared plus bx plus c, and we're going to take that and divide it by x minus d. Alright, if that's the case, here's all we do. Whatever this is, we put that out front as d. We look up here at our coefficients, and we list only the coefficients. So in this case, a, b, and c. Now what happens is, by dropping all the x's, x squareds, and everything, it makes this a lot cleaner problem. Now we're going to take this first term, and we're going to bring that down. Out here, this box is going to let us know, if it exists, what our remainder is. Now all we're going to do is take the number out front times this. So in this case it would be d times a, and that would give us dA. And then we're going to take these two terms, add them up, bring that number down here, and do it all over again. d times this, bring that answer up here, add them up, bring it down, and we do that however many times we need to. So let's take a look here at just a fairly short one. X to the fourth minus 10x squared minus 2x plus 4. So there's one polynomial. We're going to take that and we're going to divide it by x plus 3. Alright, now again, for the synthetic to work, this has to be x to the first power and a constant. Now, just like when we set this equal to 0 and solve to get negative 3, that's how we decide what goes out here. So always the opposite of what's in the parentheses. Here, all we're going to do is our coefficients. Now, like our long division that we did not too long ago, if you notice, we're missing a few things here. So we have to put some placeholders. So the biggest exponent here is 4. It's got a coefficient of 1. There is no x to the third, but we still need that term. Then negative 10 is our x to the second. Negative 2 is our x to the first. Positive 4 is our constant. So we have fourth power, third, second, first, constant. You need everything you can. Skip anything. So we bring down whatever that first number is, and then at the end, if there's a remainder, that's where it's going to go. So this is the same as doing long division with this underneath and this out front, but it's a lot cleaner to work with. So let's follow our steps. Multiply front times bottom, add these up. 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 So, what good did that do us? Well, it gave us this. Remember, if we had x to the fourth divided by x to the first, that was telling us that we'd have x to the third left. So this gets me x to the third minus 3x squared minus x plus 1 with a remainder of 1. The other way of writing this, like we did on that last long division problem, we could say that this would give us x to the third minus 3x squared minus x plus 1 plus 1 over x plus 3 as our whole remainder. So a couple different ways of writing that. Now we're going to do a lot of things with synthetic here that are going to shorten up problems quite a bit. Once we get this, if this is something we could factor, sure enough, we would factor this further down. So that's going to be one thing. Now our other thing here, a remainder, very, very important for a couple of reasons. There's something that's called the remainder theorem, and there's something called the factor theorem. And for each of those, whatever that number is that shows up in that box becomes real important. All right, so let's take a look at each of those situations, and we'll start with a remainder theorem. All right, so our first thing here, they said remainder theorem. All right, so our remainder theorem, wow, that works pretty cool. Our remainder theorem is going to help us out with a couple things. One of them, it's going to shorten up a problem that in the past, especially if you had a lot of positives and negatives involved in the problem, could really cause some trouble for you in a lot of places to get yourself into some issues too. So let's take a look at this. One thing that they could look at on this would be they could give us a function. So in this case, we'll go with f of x equals 3x to the third plus 8x squared plus 5x minus 7. All right, pretty simple. And they could tell us, all right, let's go through and let's find f of negative 2. Still seems pretty harmless, because all this does is using our function notation tells us 2 is our input. We're going to plug it in and see what our output is. So all of a sudden we can just substitute negative 2 in. Everywhere we see x. And it should be a problem you could handle. But here we've got negatives raised to the third power, which you're going to have to get the correct sign, and then multiply it by a positive 3 and keep the correct sign. And same here. And so a lot of places where things could happen. So we've got a little bit of a shortcut here. Shortcut is synthetic division. So whatever this number is here becomes our number out in the front box. This becomes our inside. So here's our third power coefficient, our second power coefficient, our first power coefficient, and our constant. So 3, 2, 1 constant, we're good. We didn't skip anything. Bring down the first number. And again, here's going to be our key. So same steps as before. Front times bottom, add them up. Front times bottom, add them up. Front times bottom, add them up. All right. Did everything we wanted. What did we just find? This is f of negative 2. In other words, we could have done all of this work up here, and hopefully if we did it all right, we would have got negative 9 for a solution. Much, much shorter and a lot harder to make any mistakes in this part right here. So, remainder theorem. Find the remainder, and it tells you what this is. So I could put any number I want out here. I could put 12 out here. And instead of doing 12 to the third and 12 squared and doing all this, I could just put 12 here, solve all this, and whatever I get down here would be what f of 12 is. So, pretty cool idea. Makes things a lot quicker, easier to work with, and way cleaner. Alright. That's one thing that we can do.